Chemistry 11.2, number 1 is force per unit area. If you just say force divided by area, I would take that. If you have the word force, I'd say you got a half. If you have the word area, I'd say you got a half. If you have the word force and area, you might have a whole point, but best answer is force per unit area. 2 is an instrument called the barometer, B-A-R-O-M-E-T-E-R, barometer. 3 and 4, you take your choice of any 2 of these numbers, but we need the right unit with the right number. So one of the things here is 14.7. If all you said is 14.7 though, that doesn't have value. 14.7 only has value if you say PSI. What does PSI stand for? Pounds per square inch is correct. You'll usually see that when you're inflating. Anybody ever have experience with this? Inflating what item you deal with PSIs? Tires, car tires, stuff like that. Average car tires probably like 32, 35, something like that. Big monster truck would be a higher number. But 14.7 PSI is a thing. 76 centimeters mercury is a thing. 760 millimeters mercury is a thing. 760 torr is a thing. 1 ATM, which stands for atmospheres, is a thing. 1.013 times 10 to the 5th pascals is a thing. Tomorrow you'll need to know those 6. If you want to do 29.9 inches mercury, that would work, but that's not one of the main ones for our book. But if you're watching the weather and they're talking about atmospheric pressure, they're probably in the United States doing inches mercury on their atmospheric pressure numbers. And then 1013 millibar, MBAR, 1013 MBAR. Question about those 4. Okay, then we're into the old stuff from yesterday, just retread. So 1 is expansion. Follow-up expansion is fills all of the space in which it's placed. So we need the word fill there for sure, but full answer, fill all of the space in which it's placed. Indefinite shape or volume, we want to use the word fit. Fits in any vessel, fits in any container. Vessel's not a magic word, you could use synonyms there, but fit needs to be a word. Compressibility is a third item. Idea there is that a large volume can fit into a pressurized tank. Low density is an idea, and what we're contrasting is the units. We're going to say grams per liter work for gases. Grams per milliliter is what you use for solids and liquids. And then mixing was the final point. Someday there's a bonus question on the test on mixing, but we're not going to do a bonus question on every single quiz that leads up to the test. Question on that club, the 13. 14, heat and motion are related. Second is the particles of matter are all in motion to some degree. And the third is that heat is an indication of that motion. In other words, motion is what causes you to notice heat. Motion is the cause. Heat is like the observable thing caused by the motion. But heat is an indication of that motion. Question on those 3. 17, gas is made up of molecules, has a follow-up explanation. Most of the volume of gases is empty space. There's no attractive forces of molecules. There's constant rapid motion of molecules. If they didn't say of molecules for those 3, let's take a half point off total. But next time I would probably do half point per as I get a little bit stricter on the scoring day by day by day. But gas is made up of molecules. There's no attractive forces of molecules. Constant rapid motion of molecules. 4th thing is that there's perfectly elastic collisions, and that has a follow-up explanation, which is there's no kinetic energy lost. The 5th idea is that average kinetic energy is proportional to Kelvin temperature. Average kinetic energy is proportional to Kelvin temperature. 24 is ideal gases. 25 is real gases. 26, it's not enough to just say temperature and pressure. You have to say temperature is low or pressure is high. That's our items on that. So low temperature, high pressure, and that's that. Question about scoring anything at all? Then let's talk about changes for next time. There's only 1 point of reading. No, 2 points of reading. One fact, but it's a 2-point fact. So there's going to be a law by a guy, has to do with gases, but 2 new points from reading 11.3. Know about the guy and his law for 2 points worth of stuff. Everything from 5 down is staying the same until the bottom level. Number 1 stays the same. Here's a new question from the reading and from my notes that didn't make the quiz this time. I'll ask what causes pressure. So if you want to jot that down somewhere up around number 1.5, what causes pressure is collisions of molecules. So these molecules that are in motion and they're bumping into each other all the time, there's all these collisions. That's what's causing pressure. So collisions of molecules, pressure. 2 stays the same. I think for the test, bonus point on this, guy's name. Anybody have the guy's name who invented the barometer? Those super reading comprehenders? Okay, so it's Evangelista, Evangelista, Torricelli, or maybe it's Torricelli, I don't know. Torricelli. How does his name connect to something else? Anybody notice a connection? Okay, I'll get back with you on that in a second. 3 and 4 becomes a 6-point question. So what I'm hunting off of this is 14.7 psi, 76 cm Hg, 760 mm Hg, 760 torr, T-O-R-R, 1 atm, and 1.013 times 10 to the 5th pascals, which is big P, little a. Not tomorrow, but someday, test bonus points. I'll sprinkle in the 29.9 inches mercury if you want to do that. I'd sprinkle in 1013 MBAR for millibars, and I'd sprinkle in that tires are 32 psi-ish. I would throw 3 extra credit questions for the test on that one someday. Now, does anybody notice a connection to Torricelli's name? The unit torr was named after him. So one of those atmospheric pressures named after him. Then 2 more new questions. You could put this in around like 4.5, I guess. There's 2 things that can cause pressure decreases naturally. Anybody with super reading comprehension or life knowledge, something that you can do that causes decreases of atmospheric pressure? One would have to do with travel. One would have to do with weather.
The higher up you...
Go ahead. You've got a good idea.
Yeah, it's the higher up you are, it's like the more pressure there is.
Yeah, the higher you go, the less pressure there is. So where in the United States could you go and you'd be dealing with lower atmospheric pressure? Colorado, like Denver, Mile High City, you know, that kind of stuff. If you go to high altitude, that causes a pressure decrease. The other thing that does it is moisture. That's why your weather forecasters will sometimes talk to you about atmospheric pressures on there if you watch. I haven't watched the news for a long time, but they used to always say the temperature, atmospheric pressure, the wind, miles per hour, all that stuff. But atmospheric pressure is sometimes an indication of what's going on in terms of rain and precipitation and things like that. So moisture causes pressure to lower, high altitude causes pressure to lower. That's all true. Grand total of that is 36. Again, on the quick run through, there's 2 new points of reading. 1 stayed the same. We added on a question 1.5. 2 stayed the same. 3 and 4 became a 6-point question, and then I added on like a number 4.5 kind of question. There is no homework that has to do with math, that has to do with anything that you have to turn in on this. If you wanted to chip a couple letters off, like you have knowledge to do 1, E and F, you could do 2, B, C, and D, but there's nothing to turn in for Monday. The next homework turn in is 2 lessons away because the new reading, this guy with his law, there's math involved in his law for gases.
Was there the extra credit on this quiz?
No, all the extra credit will happen like on the test one. We'll stockpile it all up. Anybody, any kind of questions about 11.2 scoring, 11.3, what's coming?
Can you repeat things?
3 and 4 was 14.7 PSI, 76 cm Hg, 760 mm Hg for millimeters mercury, 760 again but with torr, T-O-R-R, 1 ATM for atmospheres, 1.013 times 10 to the 5th big P little a for pascals. That's the 6 I'm hunting for next time. Then for bonus someday, 29.9 inches mercury you could use on the test. 1013 MBAR for millibars you could use on the test. And tire pressure being like around 32 PSI. Give or take, could go on the test. Depends on your car. Question about 11.2, question about 11.3. The homework I'd be happy to help you with, if it helps you get it in today with a little bit of guidance, would be we're trying to tackle a 4 to 7. I wouldn't be particularly interested in helping you with 4, 5, or 6 because you sort of want to just pull those straight out of the reading or the quiz. But I'd help you do 7 if you had trouble with the math. 7 is, in my opinion, a 5-star example of a question that could see if someone understands dimensional analysis. It's not an easy one, but it definitely breaks out all the stops in terms of can you do dimensional analysis to anything? If you can do 7, you're a dimensional analysis genius. If anybody needs some help doing 7? Yeah. Okay. So 7 starts you off with 14.7 pounds per square inch. So I'm going to go 14.7 top. We're experiencing chalk difficulties. Please stand by. So 14.7 pounds, then I'm going to go square inches down there. We're trying to convert like everything. They want us to try to get this turned into 1.013 times 10 to the 5th pascals. It's just a matter of getting there. So pounds needs to go. So where would I put pounds to make pounds go somewhere? Bottom. So pounds is going to go to the bottom. Then what we have to do is read in this list of stuff they gave us or search our human knowledge. What can pounds be turned into? Newtons. Do we know the numbers for that? Like by heart? No. Where are they though? They're in the book. They're in that list. In that list it tells you 1 Newton is, and then you can fill in the number of pounds. Do you see where it has that Newton pound number?
Yeah.
Okay, so 1 goes with newtons, the other thing goes with pounds. So pounds is out, newtons is in. Then that's okay, because they want us to get to, they're telling you that we want to get to pascals, but they also tell you a pascal is the same as a Newton per meter squared. So newtons being in, pounds going out, that's half a more drop. Okay with that? So inches also has to go out, which to make inches go out, I need to put inches on the top. And then I need to change inches into something else. We have the knowledge in this question to turn inches into centimeters. Do you see the numbers for that? It's in that same line around there.
Yeah, I
You
see.
see it? So inches is out, centimeters is in. Again, our goal is to get newtons per meter squared, not centimeters. We need to get to meters. So we need to go again. To make centimeters go out, I need on the top, and I'm trying to get to meters. Centimeters, meters is not in that list. That's the thing we just need to know. Numbers on centimeter versus meter. 100 centimeters make 1 meter. We're not done yet, but we'll pause there. Question about that jump so far.
Was it inches have a number?
Inches does have a number, it's in the paragraph. It tells you inch, centimeter, there's a, this many inches equals that many centimeters. They give you those numbers. If you can do that, you're good at dimensional analysis. We're not great, we're good, because we're not, this would be wrong. Does anybody spot the flaw in what we did and why this is incomplete? Yeah, stuff is squared. It's not just the meters are squared, the inches are squared. So if the inches are squared, we can't cancel inches that are squared with regular old inches. Does anybody remember what you used to do a long time ago when we encountered these? Long before I came onto your scene. Any memories? We'd have to wrap this up in parentheses. The number and the inches gets wrapped up in parentheses and is squared. And in fraction life, if you're ever doing that to the top, you've got to do that to the bottom too. So the bottom would get wrapped up in parentheses and get squared. Inches that are squared now got canceled by inches that are squared, but this number needs to get squared and that number needs to get squared. If centimeters are squared here, then it stands to reason they need to be squared here. So we wrap that up, we square that, and if we do that on the top, you've got to do that on the bottom. So what's left for you is you have to find those numbers in the reading, because if I gave you those, I literally did the entire problem for you. So you got to find those, and then if you push buttons, it should turn out 1.013 times 10 to the 5th, which last night was an unfamiliar number. But today, that's not an unfamiliar number because where did we see that?
Isn't that the
It's
same?
on the standard pressure.
It's one of the standard pressures. Which one was it?
PA1.
Millimeters mercury, or like what was it?
PA1.
It was the PA one. So the 1.013 times 10 to the 5th should be the result of the math, but we knew that answer going in. They just wanted you to it said, I think, show it. Use dimensional analysis to show it. So we just did that. This, if you push buttons, should produce that. Question about the dimensional analysis. These always blew people up at the beginning of the year. Anything that had square or cube units and you had to go parentheses and square and cube it, that usually blew people up in October when that was introduced to you. That's usually not a fan favorite. Is that okay enough? Should be. Anybody need any more from me in the world of chemistry? So again, to recap, no homework. 11.3 reading is not much, just one or two new points, and then a little bit of reworking today, and that's our game.